approximately dy, which is the differential. This is an approximation of the exact difference. And this is f prime of x dx, right? So if I want to determine the exact difference, let's say for cost of 100 minus cost of, I don't know, 99, this will be the exact. Okay, where x is 100 and dx will be 1, the difference between 100 and 99. But how do I determine this? Well, so this will be approximately c prime of x times dx, which is 1. And of course, x will be 100. We discussed this a lot, this formula. I cannot stress enough, redo the test, the old tests with solutions and the homework. That's why we did the homework, the written homework, in preparation for all tests and the final. I will redo those tests 5 times, 10 times if I need to, each and every one of them, till I don't need to look anywhere. Good, very good questions. I would like on Tuesday to start a little bit earlier than 7 o'clock because I allow it a little bit extra time for the final, like maybe 2 hours and a half. So maybe we can start at 6 if that's okay. Are you going to be available from 6 o'clock?
Yeah, that's fine.
Okay. Good. Anything else? Other questions you would like to work on?
Did you say 6?
I said 6. I don't know, 6:15.
Yeah, 6 is fine. I just wanted to make sure I missed what you said. So.
Yes. I would like to start at 6 p.m. only because, as I said, I allow extra time on the final.
That sounds good. Thank you.
Thank you.
And will you send us a Zoom link over email, or which link should we use?
Oh, I will create another. Don't worry.
Okay.
Of course, I realized that I didn't create one for Tuesday night.
All right. I have 2 more quick questions, but I don't know if anyone wants to stay and watch them. They're just out of the textbook again.
Oh, yeah, just any question. And
all right,
Kirsten, if you have a couple of minutes after class, just for 1 minute, I just want to say a couple of, okay.
Page 415.
415.
Numbers 62 and 71.
Very good. So let's take a look. 415. 415. Okay, this was 255. 415. 415. Got it. 62. 62. Find the area of the region bounded by the given curves. Okay, so we have y equals, and 62 is x squared, y equals x cubed, and x equals -1, and that's all. That's what you had in mind, correct?
Yeah.
Because sometimes I copy something else. Okay, good. So first of all, we have to graph. Without the graph, we don't know what, where, how. So this is the easiest one to graph. Oh, I need it solid, actually. Okay, and now let's see. When x, I'm focusing on this. When x equals -1, -1 squared will be 1. Then this one, when x is 0, y is 0, and at 1 is also 1. So this is the graph of y equals x squared. Okay, now, when x equals -1, this is -1. The graph is something like this for x cubed. So at 0 is 0, and it will also cross. We had that situation some time ago. So this is y equals x to the third. But we're specifically told the area has to touch all these three. So this is the area in question, right?
Mhm.
Good. So we have to determine the area between -1 and 0 from the upper function, which is x squared, minus the lower function, which is x cubed. Because the area has to be enclosed by. That's what they're saying. So this, and this. So the exact area is the integral from -1 to 0, from the upper function, which is x squared, minus the lower function, which is x cubed. So then this is x cubed over 3 minus x to the fourth over 4. From -1 to 0, when I plug in 0, I get 0, minus, when I plug in -1, this will be -1/3, but this will be -1/4. So everything is positive, and it has to be. So the least common denominator is 12. 4 plus 3 is 7. And that is the area. Whatever measurement unit squared, units squared. Any questions?
I was wondering if we could do a problem on page 135.
Yes, we have one more. We have 71.
Okay.
Just 1 second. Yes. Which
Oh,
one?
sorry.
Let me write it down. Which one?
On page 135, it's number 14.
Good. We'll go back to that after we finish 71. Any questions on this? Any questions here?
Nope.
Okay. Okay, so let's continue with, you said 71. This is page 5. 71, 71 is on the same page? I think you said yes.
Yes.
Okay. In 71, we have find the area, which is y equals the square root of 1 minus x squared. Y equals 1 minus x squared. X equals -1, and x equals 1. Okay, so let's take a look at those. So again, we have between -1 and 1 this time. Okay, so these are taken care of. Now let's see what these are. This is basically a circle, because if you square both sides, don't do anything just yet, 1 minus x squared. So this is x squared plus y squared equals 1. So it's a circle with radius of 1, but only the positive side of the circle. Just this. Okay? So because the negative side will be this, with a height of 1. This piece is the square root of 1 minus x squared. So y equals the square root of 1 minus x squared. Now, let's see what this is. This is a quadratic function. So this is x squared, but minus x squared is this. And with positive 1, it's shifted up 1. So instead of being here, it's here. Very interesting, really interesting. So this cannot be a circle, this has to be a parabola. And this is y equals 1 minus x squared. Right, excellent. and this is the area. Since it's even, the graph is symmetric, I'm going to determine the integral from 0 to 1 and multiply it by 2, from the upper minus the lower. So this is, the area is twice the integral from 0 to 1 from the upper, which is the square root of 1 minus x squared, minus the lower, which is 1 plus x squared dx. And we're going to have a little bit of an issue here, because with this radical. So this is 2. The integral from 0 to 1 from the square root of 1 minus x squared dx minus 2x from 0 to 1 and plus 2x cubed over 3 from 0 to 1. So we're going to have a little bit of a problem with this. Determining this. They forgot that we do not know how to determine this. I can show you how, and I will, because I want to finish it. But this is not part of this course. Okay, so this part is very easy. It's -2 and minus 0, and then plus 2/3. Because when I plug in 1, I have 2/3. When I plug in 0, I have 0. When I plug in 1, I have -2 because there is a negative in front. When I plug in 0, it's 0. But on this one, I have to show you how to determine that. Or we just calculate it with a calculator, because I'll show you. We do not know this technique. It's not presented in this class. It's not part of this class. So the square root of 1 minus x squared, the substitution here will be x equals sine theta. Why? Because it's a trig substitution. Because when I replace it in here, I will have 1 minus sine squared, which is cosine squared. The square root of cosine squared is cosine theta. And dx equals cosine theta d theta. Okay, so then 2 times the integral from 0 to 1 from the square root of 1 minus x squared dx becomes this piece. This piece now is cosine theta. And dx now is cosine theta d theta. Now the limits of integration have to be changed. When when theta is 0, sine is 0. I'm sorry. I meant to say when x is 0, sine is 0. When x is 1, sine is pi. The angle is pi over 2. And now we also have to change this into 1 plus cosine 2 theta over 2. You don't know any of these because this is from trig and trig substitutions. So this is theta from 0 to pi over 2 plus cosine 2 theta. So this will be sine 2 theta over 2. Because when I differentiate this, yes, from 0 to pi over 2. We're going to do this with a calculator, but since I have to show you, I'm showing it. So pi over 2 plus 1/2. This is 0. This is 0, and this is 0. Okay, so this is pi over 2. So now the entire area is pi over 2 minus 2 plus 2 over 3. And we're going to check. So this is pi divided by 2 minus 2 plus 2 divided by 3. 0.23746. 0.23746. Okay. So just to show you, no, you're not going to have to do this. There is no discussion there, right? So I showed you that, but be very careful when you use this, because if you don't enter the function correctly, and then you may waste your time trying to figure out what's wrong, or maybe your answer is not incorrect. Okay, so please be very careful with this. So now I'm going to calculate so you can see the answer is the same. So I'm going to put the 2 in front, and then the integral from 0 to 1. And be very careful how you enter this. It has to be the square root. You don't know how to calculate that integral, so don't even worry about it. Okay, so you just have to trust me on this. And minus 1 and plus x squared. I don't know why they put that problem in this section. Or maybe it's at the end or reviews or something. I didn't look. Okay, so the answer I got is 0.23746. Okay, so, but again, we don't know how to calculate this first part. The substitutions that we learned in this class are not enough. They will not help us in this case. Okay, so that's part of Calc 2. Good, it was a good problem. It was a good problem. Where is my, what was it? The other one was 14 on 135. Good, so let's take a look. 135. So what was this? So it was in 4.4. Yeah, it should have not been in there. They dropped the ball. 135, 130, 135, 135. Okay, problem 14, 14, 14. Yes, so what we want here, graph the function, draw tangent, lines of the graph at the points, and find f prime by determining the limit. Yes, okay. So we're not going to graph the function. It's just quadratic. So we can find the vertex, the x and y intercepts. So that's part of algebra. Draw tangent lines of the graph. Yes, we can do that. So let's determine the limit. Let's determine the derivative first. So this is the limit as age approaches 0 from f of x plus age minus f of x divided by age. So this is the derivative. So remember, we always have some preps to work on, and this is the first prep. And the function, let me copy the function. I didn't copy the function. 14, 14. Okay, so negative 2x squared plus 3x minus 2. And after that, they want f prime of negative 2, f prime of 0, and f prime of 1. Good. So remember, this is, for this quadratic function, it's better to...
You're still sharing your screen.
Oh, thank you. Sorry about that. Okay, so for a quadratic function, if it were anything else, basically, I would not do this, unless it's a polynomial, of course. But I would prefer calculating this on the side, and then I'll come back to and continue here. So remember, f of x plus h is negative 2, x plus h squared plus 3, x plus h, and minus 2. So negative 2, the x squared plus 2xh. Now, I know you're dreaming about this, right? 3x plus 3h and minus 2. So this is negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h and minus 2. Because if I write this 15 million times, it will take me a long time, right? So I recommend calculate this on the side. And now I will continue. And remember what has to happen. All terms without age must go away, and then you have to simplify the age in the denominator. That's mandatory. Otherwise, something is terribly wrong. So then limit as age approaches 0 from negative 2x squared minus 4xh minus 2h squared plus 3x, watch me run out of room, I always do, plus 2x squared minus 3x plus 2. Look at that. One time I did not run out of room. So these two are gone, these two are gone, these two are gone. No, this. So this is gone, this is gone, and the negative 2 is gone. This is not. So I see there are 3 terms left. These 3 are gone. 1, 2, 3 are gone. So I have this, and I have this. They all have age in common. So I have to factor, because that's how the age goes away. So I have negative 4x minus 2h and plus 3. And when age approaches 0, I have negative 4x plus 3, which we knew from the very beginning. You should always determine this with formulas now, right? So negative 4x plus 3. I know exactly what I need to obtain. If I don't obtain negative 4x plus 3, I know I'm in trouble. So now I'm only asked to plug in negative 2, and I get 11. I'm asked to plug in 0, and I get 3. And I'm asked to plug in 1, and I get negative 1. And then if I graph the function, the graph has a maximum. And let's say at negative 2, I will draw the tangent. At 0, I don't know where 0 is. I guess I didn't graph the function. I just... Okay, that's all I need to show. The tangent at those points. Is that